Okay, so the area of the trapezium in the diagram is 28, and a rectangle of length x plus y and width y has area 43. Show that xy is 28 minus 2y, and xy equals 43 minus y squared. Now, we need to remember the area of the trapezium, okay, and that would be half bracket a plus b times h. They don't give that to you in the additional exam, you've got to remember it. So half bracket a plus b h. So, and remember, of course, the a plus b, or the a and b are the two sides that are parallel, yeah? So these two sides, so that could be my a, that could be my b. So I've got x plus 4 there, my b is x. So add them, a plus b, and then times it by the height between them, times it by that h, which is y, okay? And that would equal to the area of the trapezium, which is 28, okay? So we could say that. So the area formula, and we know the answer is 28. What I could do then, maybe I'll leave that half there for a minute, but in that bracket, I could do, I could simplify that. That would be 2x, add 4, times y is 28. And what's good then is, because that's 2x plus 4, because they're both even, I could take the half through the bracket. I could sort of take it in, and half times 2x is x, and half times 4 is 2, okay? That makes sense. I'll keep a bracket there because I've still got the y there, haven't I? I've still got the y to times as well. Okay, so I need the bracket to still be there because I've got to times by the y, but what I've done is I've just times through by the half, yeah? Half times 2x, half times 4, and it gives me that. Half of 2x is x, half of 4 is 2. But I've still got to times by the y, equals 28. And then times by the y, I get xy plus 2y equals 28, and I get what they want. Okay, get that there. Now, with the rectangle, okay, rectangle is easy because all you've got to do is length times width. So basically, y times x plus y. Okay, that times that is equal to 43. Times through the bracket, so I get xy, y times x is xy, y times y is y squared, and that equals 43. And then if I take that over to the side, I get that, so I get exactly what they want. It says then b, hence write down a quadratic equation in terms of y, and to calculate the lengths of the parallel sides of the trapezium, you may use an algebraic method. Now, because we've got two expressions for x, y, right, they are the same, aren't they? X, y is the same, so we can say, look, this is equal to this, quite simply, right? So we can say, look, therefore, 28 minus 2y is equal to 43 minus y squared. So we can do that. Get all this side thing over the other side, so minus y squared over becomes y squared. I've got plus 28 minus 2y, right? And then take the 43 over as well, so it'll be minus 43 equals 0. That will be y squared minus 2y, and 28 take away 43 is minus 15 equals 0. So I've got myself a quadratic, and I can solve it. I have two brackets. Okay, so two numbers that multiply to give minus 15, okay, and add up to give minus 2, while 3 and 5 I think will work. If I make that a minus 5 and that plus 3, that will add up to give me that, and times to give me this. So plus 3 minus 5 equals 0. So that means y plus 3 is equal to 0, or y minus 5 is equal to 0. So then we've got y equals to minus 3. And of course, this would be impossible, wouldn't it? You can't have y to be minus 3. Because remember, y is this here, yeah? So that's not going to work. Can't have a negative length, so therefore y will equal 5. That's my answer for what I need there. So if I got y to be 5, I can then work out what my x is, okay? Because that's what we want, isn't it? We want the sides of the parallel sides of the trapezium. So I just got to sub this then into one of these, okay? So maybe put it in there. So I'll have x times 5 equals to 28 minus 2y, which is 2 times 5. So 5x is 28 minus 10. 5x would be 18. So x would be 18 divided by 5, which is 3.6. Okay. So if x is 3.6, so one side will be 3.6, and the other side will be 3.6. Add 4, so 7.6. So we've got the two parallel sides there.